Alright, so this is solving one-step addition and subtraction equations. So anything you see today is going to be either addition or subtraction, nothing else. We'll tackle multiplication and division at a later time, I think tomorrow. So anything today is addition or subtraction. You need to make sure you write down some examples because I don't want you to get to your worksheet and say, well, I don't remember how to do this. Okay, so you have to show some examples in your notebook today. Alright, so the first thing, I have a few vocabulary for you, and if you want, you can leave a little space in between because I'm going to show you some examples of these once you're done writing. So you can have some examples of what an equation is, what a solution is, and what equivalent equations are. So leave a little space in between those, and then I'll give you some examples of them. Okay, so here's the thing about equations. You've been dealing with equations your whole life and you didn't even know it. Okay? This would be considered an equation. Okay, if I say the definition is this, a sentence stating that two quantities are equal, why would I say that this is an equation? Brandon. Okay, maybe. Why would I say these two things are an equation? Why would I say this is an equation? Yeah, Eric. Okay, I think you're kind of guessing the right thing. What's 1 plus 3? Is 4 equal to 4? Okay, so a lot of us don't see it that way. You say to yourself, 1 plus 3 equals 4, and you don't think, okay, 1 plus 3 is 4, and that's equal to 4. That's an equation. Think about it. Both sides are equal, are they not? Are both sides equal? 1 plus 3 is 4. Is that equal to 4? Okay, so here's another example in an equation. This is another example in an equation. Okay, why would I say this is an equation? Tessa. Okay, and then what? And then I know, guess what this side equals? 7. Does 7 equal 7? Okay, that's an equation. You've been doing this and you don't even know it. Okay, so what about a solution? So if I give you this, m plus 5 equals, I don't know, 6, you know at the top of your head, what does m equal? When m equals 1, that's considered a solution. Okay, that m plus equals 1 is considered a solution. You're going to be finding solutions today for equations. Okay, equivalent equations, this is when two equations have the same solution. So for an example, you can have this. Why would I say these two things are equivalent? Hunter? Yeah, they both equal the same thing. What do they both equal? Those two are equivalent. Okay? So you can have a ton of equivalent equations. You could have 3 plus 9 is the same as 6 plus 6. They both equal 12. They are equivalent. Why? They both equal the same thing. Okay? Does everybody have some examples written under these? Okay. So, my next, I'm not going to have you write these down, but I'm going to go to this. What is this? A scale or a balance. I would probably call it a balance. Or scale, I guess, either one. All equations are like all equations are like they're on a scale. Okay? Here's an example. Okay? First of all, what do we know about a balance or a scale? What do we know about it? Bo. Okay, so more weight on one side, the lower it goes. Okay? Or the less weight, the higher it goes, right? Either way. Yep. Yeah, if I put the equal amount of weight on each side, it's going to be level. So it's going to stay like this. And like what Bo said, if I put something heavier on this side, it's going to go like this. And if I put something lighter, yeah, that's just how a balance works. So that's exactly how an equation works. So let me show you. So I'm going to use this to show you exactly how an equation works. So m plus 3 equals 5. Okay, so do you see how my middle is like my equal sign? Because both of these sides have to equal the same thing. Now let me draw on my scale what this looks like. Okay, this looks like this. M plus, and then for 3's I'm going to make like tiles. Okay, and this side I'm going to draw 5 tiles. Okay, are they equal right now? Yep, they're equal right now. But my job is to find out what that M is. And I know you all know it's 2. But how do I know what that, you know, you can just tell off the top of your head, but I'm going to show you what it actually looks like here. Okay? So, remember, if I do something to one side, I got to do it to the other side to make it equal, right? And my job is to keep my equation equal at all times, because if I don't, I'm not going to get the correct answer. So I have to keep my balance equal on both sides. So my job is to find out what this equals. So the first thing I'm going to do is I'm going to take one away here. If I take one away here, what do I got to do? I got to take one on the other side. Am I still equal? But my job is to find out, well, what is M? My job is to get M by itself over here. That's going to help me tell me what M is. So if I take one here, what do I got to do to the other side? Yep. Okay. Do I have M by itself? So guess what M equals? 2. Okay, that's how the balance works. So what I did on this side, did I have to do on that side? You have to do it on both sides. So let's do it again. We're going to do another one. If you want to draw it, you can draw it. So let's do M plus 2. So I'm going to have M plus 2 equals 6. 1, 2, 3, 4, 5, 6. So do I have to go by one at a time? No. Could I take 2 here right away and just forget about it, and then I don't have to go back and forth? So if I do 2 here, what do I do on the other side? 2 on the other side. Do I have M all by itself? So what does M equal? 4. Now let me show you how this looks with an actual number instead of having things on a scale. So if I were you, I'd write down an example. So this is our first example we're doing together. X plus 6 equals 4. Now, think about it. Think about what we just did. This is like our scale. This is one side of our scale. This is the other side of our scale. This is like the middle bar. Okay? Now, my job is to get what by itself? X. So if I have plus 6 here, what am I going to do to that scale? What am I going to do to that 6, Bryn? Yep, imagine I have 6 boxes, and then what am I going to do with them? I'm going to take them away, right? Isn't that what I did on my scale? So I'm going to show that. When I subtract 6, that's like taking them away. What do I got to do on my other side now? I got to subtract 6. So then what I like to do is I like to make a line, because that tells me like what my answers. I did all my work up here. So then I make my X, my equals. Well, what's 4 minus 6? Negative 2. There's my answer. Okay. Drake, did you write an example down? Now, how can I tell this is right? If I say, well, I don't know if that's right, what can I do to figure out if that is right or not? Bo. Put it back in. Right, I think is what you're saying. So what did I say x was? -2? So I'm going to rewrite that. -2 plus 6 equals 4. Is that right? All right, then I'm right. Okay. All right, let's try another one. Let's try another one. Let's do one like this. What's different about this one? Okay, it's a negative, it's backwards. It doesn't matter. Doesn't matter. Maybe it's in the middle. Okay. It doesn't matter. It's still an equation. So if you want, think about it this way. Okay, my job is to get what by itself? The letter, right? So B. So let's work on this side first. Let's pretend I have 8 boxes again. What am I going to do with those 8 boxes? Oh, no, no, no. What am I going to take away? Wait, I have 8 boxes on this side. What am I going to do with those 8 boxes? What do I want by itself? So I got to get rid of those 8 boxes, right? Anything that's with my variable, I want to get rid of. So let's subtract 8 boxes here. That's like me taking them away. Now what do I got to do to my other side? I got to subtract 8 more boxes. So I have something equals B. Now I have -5 minus 8. -13 is my answer. So you have to be careful with your keep changing it. Okay, let's try another one. Then I'm going to do one more with you, and I'm going to let you try one by yourself. Try, let's do this one. Okay, so y plus 6 equals 9. What am I going to find by myself? What has to get, what? Okay, so I have y plus 6. What do I want by myself all the time? The y. That has to be by itself in the end. So if you want to pretend I have 6 boxes over here and 9 boxes over there, what am I going to do with those 6? I'm going to get rid of them, right? Okay, what am I going to do to the other side? Yep, that's like me erasing those boxes. Y should be 3. Okay, you have to show me your work. The reason why you have to show me this is because when we get to multi-step equations, which will happen, which means it's multiple steps, you have to show your work because otherwise you're going to forget where you're at. So get in the habit now of showing your work. Got it? All right, do this one for me. Do this one for me. Let's do this one. Don't let that negative screw you up. Think to yourself, okay, this is my one side. This is my other side. I need A by itself. Show the work. If you show the work, it's going to make your life a lot easier in the long run once we get to multi-step equations. Did you show your work? If I want this by itself, what do I got to do with this? Yep. But I got to do that over here too, right? -3 minus 4 should be -7 equals A. -7. It's not 1. Some of you had 1. It's an A. Sorry, it looks like an I. Okay, try this one by yourself. I'm going to give you another one. Do this one. Z plus 4 equals 10. Show the work. Even though you already know, show the work. Z plus 4 equals 10. Tell me my first step, somebody I have not heard from. Tell me the first step I'm going to do. I've heard from you already, sorry. Keaton. Okay, because what's that like? That's when you subtract in those 4 boxes, right? Somebody else, tell me my next step, Brent. Yep. And what do I have? Z equals 6. Should be my answer. Okay, let's do a few more. Let's get to something like this now. What do you notice about this type of equation? It's a subtraction equation. Here's a hint to you. Okay, did you notice before when we had this we were subtracting? Did you notice that? When we were adding, we had to subtract to get rid of. What do you think we have to do up here now? We have to do the opposite. Because it's basically like me taking this away and that says -2. What do we do to get rid of negatives? We have to cancel them out, right? Everything we've done, we've been canceling out. So instead of subtracting, guess what I'm going to do? I'm going to add 2 on both sides. X equals 3. So anytime you're subtracting, you're going to do the opposite, and you're going to add. Anytime that you have a sign in here, you're going to do the opposite, no matter what. Okay, you're doing the opposite of, if it's an addition, you're going to subtract. If it's add, or if it's subtracting, you're going to add every single time. Okay, let's look at this one. Make sure you get one of these in your notebook. Make sure you get a subtraction in your notebook. You're going to want it. So you can still think of it as a balance. You want. So I have t minus 4 equals -2. And I want to get t by itself. Every time I want to get that variable by itself. So if I have a -4, what am I going to do to cancel that out? I'm going to add 4. What do I have to do to the other side? I have to keep my balance in balance. Right now it's not. I got to add 4 to my other side. So I have t equals, I have -2 plus 4, be 2. Yep. -2 plus 4. Are you catching on? Are you getting examples in your notebook? All right. Are you? I hope so. I really, really hope so. All right, I'm going to give you one I want you to do by yourself. Do that one by yourself. You always want that variable by itself, so you want to cancel that number out with that variable all the time. Make sure you're watching your sign. It's really important. All right, somebody I haven't heard from. First step. First step, somebody I haven't heard from. Kenzie. Okay, that cancels out, but that leaves my balance unbalanced. Now what am I going to do? Somebody else I haven't heard from yet. Cora. Correct. So then I have Q equals -1. Nice job. What if sometime this will happen? You will have this. What do you notice about this one? What's different than the ones we've done? What's changed? Okay, not a big deal. What's my sign here? Is this a positive or a -6? Okay, so what do you think I'm going to do to that 6 to get rid of it? I'm going to subtract. Okay, this time we aren't looking at this sign. We're looking at the sign whatever in front of the number. If there's no sign, what do I think it is automatically? Yep, positive. So this time I'm subtract 6, y still equals, you're going to run into something like this where your variables are flipped and your your variables and your numbers are flipped. Look at the sign that's in front of the number to tell you what you need to do to get rid of it. Does that make sense to everybody? I'm going to give you 2 before you leave here, so you have something in your notebook if you didn't already. Are you ready? And I want you to do them out on your paper, actually. That's a Z. Maybe I'm not going to use Z. It looks too much like a 2. Let's use an m. There we go. Okay, so I have y plus 4 equals 19, and then my second one is m minus 10 equals negative 3. Do both of them. I'm watching my people up in front. They're doing it in steps. They're not just telling me the answer. They're actually doing the steps and using the lines on their paper. I like that. It's going to help you if you do that in the long run when we do multi-step stuff, which we'll get to here, sorry. All right, somebody I haven't heard from. Let's talk about this first one. M or y plus 4 equals 19. Trevor. Okay? Okay. Nice job. Yep. Okay, so then nice work. Nice job. Y should equal 15. Somebody else I have not heard from talk to me about this one. Aiden? Okay, because we're canceling. Very good. Okay. Nice job. Any questions?